Hello everyone, welcome back to our channel. So in this video we are going to learn an important array problem which is very popular in coding interviews, competitive programming and DSA exams. The problem name is product of array except itself. So which means this problem helps us to understand array traversal, prefix and suffix concept, optimization technique and how to avoid the division in programming. So let me first define the problem clearly. So here is our definition, which is given an integer array num. We must return a new array answer such that answer of I is the product of all elements of number except nums of I without using division. So which means our array is given as a nums and we have to create a new array. So which the new array have answers of the all the products which except itself. So here answer of I equal to product of all elements of nums except nums of I. And here our condition is we do not use the division here. So without division we have to calculate the product of elements. So this is our input and output. So our input is 1, 2, 3, 4, right? And our output is 24, 12, 8, 6. So let's see how our answer will be. So how the answers came. So uh, so in a traversal, we are going to take the index 0. So in index 0, we have a element 1. So we have to multiply the other elements except the 1. So except 1, we have 2, 3 and 4. So we have to product these three elements, which is 2 into 3 into 4. So 2 into 3, 6, 6 into 4, 24. So in our output, so the first element is 24. So after first iteration, we'll go to the second iteration. So in the second iteration, we go to the first index. In our first index, we have the element 2. So we have to calculate the prefix of the 2, which is left hand side of the 2. So in the left hand side we have only 1. So the element is 1. So on the right hand side of the 2 we have two elements which is 3 and 4. So we have to multiply the both values from the left hand side and the right hand side also. So in the left hand side we have only 1. So 1 into. So on the right hand side we have 3 into 4. So 3 into 4 is 12. So here 1 into 3 into 4. So which is 12. So and next iteration it go to the third day. So so on the next iteration go to the next index. Our index is 2. So here it will calculate the left hand side as well as the right hand side. So on the left hand side we have the 1 and 2. So on the right hand side we have 4. So we will calculate this. So 1 into 2, 2. So 2 into 4, 8. So here our answer is 8. So 8 is stored here. So and after the iteration, it will go to the last index. So last index, it will check with the right hand side and the left hand side. So on right hand side, we don't have any element, so skip it. So it will check with the left hand side. So on the left hand side, we have elements, three elements. So one is 1, 2 and 3. So if we product this, we'll get a 6. So this is how the product except itself is going to work. So let's understand this with a real life example. So imagine each number represents daily sales of a shop. So you want to calculate the total sales except one shop. For each shop, exclude its own value, multiply all the product shop values. So this is exactly what product of array except plus does. So let's see the approach. In the approach, we have two methods. One is brute force approach, another one is optimized approach. So let's see the brute force approach first. So at first, let's think like a beginners. So brute force idea. For each element, loop again. Multiple all elements except itself. Right? So here is a pseudocode. So in first for loop, we declare product equal to 1. And in a second for loop, we are checking the condition. If so what is a condition means? The number itself, it should not product, right? So we are uh, so we are so we are giving a condition. If I not equal to j, we can multiply. So this is what brute force approach, right? So it will take n square times. Time complexity is n square times. So it's take a lot of time, right? So here, so why we don't use this approach? Because time complexity. So it takes because n square. So we have to use two loops. So it take a more time. So and it's not suitable for large arrays also, and it is not accepted for interviews. So interviewer always need the optimized problem, right? So we cannot use this method in a interview. So we need a optimized approach. So let's see the optimized approach. So here is a optimized approach. So for the optimized approach, we are using a prefix product and the suffix product. So in an optimized approach, we are going to use two types of product. One is prefix product and the one is a suffix product. So which means, so if we have this, so take let's take this element which is 1, 2, 3, 4. So for the element 2, we are going to find the prefix product and the suffix product. So for element 2, prefix, which means before, which is a left hand side. So we are going to product the values. And if the suffix means in a right hand side, which is after the element. So we have a 2, 3 and 4. So we will product this. So that is what prefix product and the suffix product. So let's see what is prefix product first. So prefix product means left side. So at index I, prefix product equal to products of all elements before I. So if it's our element is 2, we will product the before, which is the left hand side. So we will product all the elements. So that is what. So let's see the example. Mm. So of the prefix of the array. So if we take a 1, we don't have any element, right? So just written as a 1. So here, so it's a product, right? So we can just written as a 1. So for the first index, our prefix element is 1. So let's written a 1. So for our next index, we have, before we have two elements, 1 and 2. So 1 into 2, our value will be 2. So 2 is written here. So and here, and our next index, in a index, in a third index, before we have a three elements, 1, 2 and 3. So if we multiply these elements, we will get a 6. So that is what prefix array. So let's see the suffix array. So suffix array means which is right side. So suffix product equal to product of all elements after I. So we calculate suffix using a variable instead of array. So for example, so our final formula. So the array answer is our answer which we are storing all the answers in a array, in a answer array. So for that our final formula, prefix of I into suffix. So this avoids division and works even if 0 is present means also. So let's see the algorithm. So at first we are going to initialize an array answer of n size. So if our element is n number of size, of course the array answer also will be n number. So and set answer of 0 equal to 1. So which is our first index is 0. So and traverse from left to right. So we are traversing from a left index to the right index and store prefix product in the answer and initialize sum equal to 1. Traverse from right to left. Multiply suffix with answer of 5. and added the suffix. So let's see the pseudocode here. So which we get our array element. So here n equal to length of nums, which is getting a length of our array. So here answer equal to array of size n. So the array element size will be our answer array size. So we are declaring answer of 0 equal to 1. So which is our first index equal to 0. So here prefix product. So we are going to find the prefix product first and follow to suffix product. So for the prefix product, we are going to start from the first index to the last index, which is left to right. So for that, in a loop, uh, in a loop, answer of I equal to answer of I minus 1 into answer of into nums of I minus 1, and declaring suffix and initializing suffix equal to 1, and in a for loop we are going down from we are reversing the we are traversing from a reverse, so which is from right hand side to left hand side, from last index to zeroth index. So we have saw the formula in previous, right? Answer of I equal to answer of I into suffix. So suffix equal to suffix into nums of I. So for producting the values. So and return the answer. So we will get. So let's code it now. So let's create a class. Mm, So product accept itself. So our class is creator. Let's create our main class. So inside our scanner class. So let's get our input. Int n equal to sc dot nextin, and int nums equal to new int. So n number of arrays will be stored in the nums of I. So na nums array. So next we are creating a answer array. So in answer array, new int of n. So how many elements is present in the nums is will going to present in the answer array also. So let's take it as a n here also. So after that, so let's get the input for the nums array. So for int I equal to 0, I greater than n, I plus plus. So nums of I equal to sc dot nextend. So we have declared the array also, answer array also, and nums array also. So let's initialize um our let's initialize answer of 0. So in our answer array, the 0th index will be a element 1. So and we do the prefix product also. So from a left hand side to the right hand side, and our answer of I equal to answer of I minus 1 into nums of I minus 1. So what's the product of each of the number itself? So let's do. So now we are declaring our first element in a answer. So answer of 0 equal to 1. So we have declared. So now we are going to traverse from the left hand side to the right hand side. So int I equal to 1 and I greater than n I plus plus. So here answer of I equal to answer of I minus 1 into nums of I minus 1. So after this, so we have do a we have done a code for the prefix product. So now we are going to run a code for the suffix product. So in a suffix we are going to initialize suffix equal to 1. So and we are going to traverse the array from right hand side to the left hand side, which is our last index to the our 0th index. So here answer of I equal to answer of I into suffix. So suffix equal to suffix into nums of I. So let's do this. So we are declaring in suffix equal to 1. So in a follow we are traversing from the last index. So in I equal to n minus 1 and I less than equal to 0 and I minus minus we have to use here. We are decrementing, right? So answer of I equal to answer of I into num into suffix. So we have calculated the value. So after we are adding to the suffix. So suffix equal to suffix into nums of I. So we have done. So now we are going to print the array. So in follow int I equal to 0, I greater than n and I plus plus. So in SOPLN we are going to print the answer of I and let's give a space also here. So let's run this code. So our length of the array, let's take it as 4 and 1, 2, 3 and 4. So we have already seen, right? If we take the element 1, our product will be 24. So just 2 into 3 into 4. 2 into 3 is 6. 6 into 4 24. And if in the next iteration it will go to the second index. In a second index we have a prefix as 1 and suffix as 2 element, which is 3 into 4 will get the answer 12. So on next index we have a element 3. So in for 3 in prefix we have a 1 2 and suffix we have 4. So if we product this we will get a 8. So after this we come to the last index. In the last index we have only prefix not suffix. So if we product these prefix we'll get a 6. So let's see. So our answer will be 24, 12, 8 and 6. So let's see. So we have got right 24, 12, 8 and 6. So thank you.